All right, we've finally come to the end. You're almost done learning your multiplication facts. Hooray! So let's look at this multiplication table and see what you've already learned. All of the products that I've highlighted are products that you've already learned. All of these, except for these last four. So really today, you only have 4 new products to learn. Because as we did all these other facts, you've done them all with 11 and you've done them all with 12. You just haven't done these 4 at the very bottom corner. So that's really all you have to learn, the only ones that you're going to learn. You've learned how to use solve multiplication facts for numbers, without an I. Yep, I spelled that wrong. And Savannah, if you didn't catch that, I did. Through 10. Today you will learn the multiplication facts for 11 and 12. Just like the rest of the facts we've learned this week, we'll look at how we can break these factors apart. Now, what's an easy addition fact that I can use to find 11, 10, oops, I don't want to use 10 plus 1. What's an easy addition fact that I can use to find 12? 10 plus 2. What facts do you know that can help you multiply by 11 and 12? Yep, our 10s and 1s and our 10s and 2s. We're going to use that strategy and apply it to solve a couple problems. And let's start with a couple of 11s. So I said I can use my 10s and 1s to solve my 11s. So let's break that 11 apart into 10 and 1. And I'm going to multiply each of those times 9. So 10 times 9 equals 90. And 1 times 9 equals 9. And if I add those together, I get 99. That means 11 times 9 equals 99. 11 times 7, I'm going to break that apart into 10 plus 1. 10 times 7 equals 70. 1 times 7 equals 7. I add those together, I get 77. Now you might notice something about our products, 99 and 77. So keep that thought in mind because we'll come back to that. And we're going to take that strategy again and we're going to solve a couple of our 12s using that same strategy. 12s, remember we added 10 plus 2, so I'm going to use 10 times 9 and 2 times 9. 10 times 9 is 90. 2 times 9 should be an easy one, that's a double, is 18. When we add those together, we get 108. 12 times 6. I'm going to break the 12 apart into 10 and 2. 10 times 6 equals 60. 2 times 6 equals 12. Add those together, you get 72. So using our 10s and our 2s for our 12s, using our 10s and our 1s for our 11s. But now let's think about let's go to something else. Let's take a look at our 11s facts and let's take a look at our 12s facts and see if we can find some patterns in our 11s and our 12s. And I bet you already know this, many of you already do, that if you notice the facts, the products in the 11s facts, 1 and 1 and 2 and 2 and 3 and 3 and 4 and 4 and 5 and 5 and 6 and 6 and 7 and 7 and 8 and 8 and 9 and 9, it works all the way up to 11 times 9. The product up to 11 times 9, I should say the products are doubles. Two 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s, 2 7s, 2 8s, 2 9s. Well, we sort of we don't get 2 10s, but we get a double 11. But our pattern sort of changes once we get to our 11 times 10, our 11 times 11, and our 11 times 12. Now here we do have a little bit of a pattern too, because you can think about your tens here when you're doing 11 times 10. We always take the other factor and add a 0 to it. So here we have 11 and a 0. Here we have a 12 and a 1 and a 13 and a 2. I bet if you did 11 times 13, you might figure out that you get a 14 and a 3, because it would be 11 times 13 is 143. Now that pattern will go on again too, and then it changes again, right? But for the most of the ones that you'll do are your single digits up to 9. Notice that they are double digits, right? Let's look at the 12s and look at our products for the 12s. Now these are doubles, but you should notice several actually patterns. First thing I notice is that all of the ones, the digits in the ones place, are all even. Digits in the ones are even. It goes 2. Let me change colors here. 2, 4, 6, 8, 0. 2, 4, 6, 8, 0. 2, 4. And if we continued on, we would get a 6 and then an 8 and then a 0. So we have a pattern here. We've got 2, 4, 6, 8, 0 in the ones place. Now what happens to the tens place? Go up a little bit. Look at the digits in the tens place. And the digits in the tens place starts with a 1, and then a 2, and then a 3, and a 4. But we don't have a 5, do we? But we get a 6, and a 7, and an 8, and a 9, and then we sort of have a 10. But then we skip the 11, and we have a 12, we have a 13, and we have a 14. Now there is a pattern here, but it isn't as easy to see the digits in the tens place. 1, 2, 3, 4, skips a 5, 6, 7, 8, 9, 10, skips the 11. All right, that one's not as easy to see. The easiest one to see though is that all of the products are even. So all the multiples of 12 must be even. Now if I look back at the multiples of 11, nope, they aren't all even, but they aren't all odd. Those patterns, the pattern here, it goes odd, even, odd, even, odd, even, and so on. So we even have an even odd pattern in your 11s. But overall, they're very simple to solve because 11s are doubles for most of your products, and 12s are all even products. So really, what you're only learning today, let's go back to these, are these 4 new products right here. Oops, not that one, because that only goes to 100. I don't want that one. I want this one. These are the 4 new products you're learning today. 11 times 11, 11, 12 times 11, here, and here. And it's really 3 products because 132 and 132 are the same. So 3 new products, really. And then you've got them all. You've learned all of your facts for your 1s through your 12s. And now you're on your way to being multiplication masters. And you just need to practice.